Well, good morning, everybody. Welcome back to the channel. Thank you all so much for tuning in. Before we get started with today's video, I just wanted to take a moment to thank you for yesterday's support on both the video as well as the YouTube short that I put out, and that was pertaining to yesterday's severe weather outbreak across much of the central and southern Mississippi Valley region, eventually getting all the way back into the Carolinas. We had a lot of severe weather reports and even some deadly tornadoes yesterday, which we'll touch on more in a moment. But I just wanted to take also this opportunity to share our thoughts and prayers with those that have been impacted by the tornadoes yesterday. We unfortunately had three fatalities. I believe they were in Tennessee. So there were a couple of tornadoes in Tennessee. We had some in southern Illinois. And then we also had some back towards Huntsville later on into yesterday evening. So again, our thoughts and prayers go out to those that were impacted by yesterday's events. Of course, we will keep thinking of you and hope all the best. I know it's going to be a very long recovery for many. And, you know, it seems like this severe weather pattern that we're in just doesn't end. You know, it just feels like this broken record we've dealt with over the last couple of weeks. But thankfully, you'll be happy to know that we are going to see a little bit of a break towards the end of the week. I may touch on that here at some point during the video, but again, today's focus is going to be on the next severe weather threat, which is going to be the same system, but this time we're going to be talking about more of the southern states in the lower 48, from the eastern Texas all the way back into the Gulf Coast states of Mississippi, Alabama, and then eventually South Carolina and Georgia. Just a disclaimer, this video is being released as of this morning, so check the latest on your local forecast with the National Weather Service, as well as local media outlets for the latest information. So this is an early morning video, and it also is subject to change. Now, at least as of this morning, what we are looking at is the remnants of what we saw last night. So this big complex of showers and thunderstorms continues to move across the southern United States this morning. And we actually saw, sort of an MCS move through the Carolinas and even Kentucky last night. We talked about that during yesterday's video. The idea of starting out with sort of the supercell, semi-discrete supercell environment, and then eventually seeing those converge, cold pool, and merge together and produce one big cold pool, or what we call a outflow boundary, or BOECHO, MCS, derecho, etc., right? Now, I don't believe we saw a derecho yesterday by criteria, although that might be reassessed today. Either way, we saw a very large complex of showers and thunderstorms starting in Kentucky and then eventually racing southeast into Virginia, North Carolina, and South Carolina last night. We're seeing the same thing again this morning with a Boeing line structure continuing to move towards Augusta, Georgia, and towards essentially Hilton Head Island by the time we get to later on this afternoon, sort of the Atlantic side of the Carolinas. So that's going to move through later on this morning into the afternoon, and then we are going to see our next round of severe weather later on this evening, and we'll get more into how that all comes together here in a moment. But the other focus is we are seeing some showers and some rumbles of thunder across the lower Great Lakes this morning. That's not going to be severe. As a matter of fact, this is relating to our low pressure system that's moving across northern Illinois this morning. That's going to continue to move off towards the east. So the most we're going to see out of this for folks in the lower Great Lakes is just going to be some showers and a couple rumbles of thunder. Otherwise, that should clear out by this afternoon, and we should see some mainly dry conditions. And for the rest of the country, for the Northeast, as well as the Pacific Northwest and the West Coast of the United States, mainly dry conditions, with the exception being places of higher elevations that are seeing some snowfall. Again, this is at very, very high elevations, probably northward of 5,000 feet, in places like Breckenridge and some of those resorts in Colorado and Wyoming and Utah. But otherwise, a pretty quiet day for you folks. You can see some of that marine fog over in San Francisco. That's starting to erode as we start to get that sun to rise and erode that cloud deck. But for the most part, besides the Midwest and the Southeast, we are mainly quiet, which can't complain about that. We've been very active for many of us here, as I said before, over the last couple of weeks. So let's real quickly, before I dive into the severe weather threat for today, I just want to recap yesterday's severe weather reports. And this is as of this morning. Now, keep in mind, as I literally get something in my eye, I hate when that happens. Oh my gosh. You can tell there's no takes in this, right? So with the storm reports we have from yesterday, as you can tell, it sort of followed the same pattern that the model output projected, right? So we did have sort of this supercell activity, very short window across St. Louis earlier on in the morning. But then we started to transition more towards this MCS complex by later on in the day. And how you can really tell is just look at your storm reports, right? I mean, most of your tornadic activity centered in the area of the moderate, which I would actually argue somewhat verified. But then as we got into the evening hours, we saw that cold pooling taking place where we have these cells that sort of start out discrete to semi-discrete. Eventually these merge and then form a bowing structure, right? So I just want to draw that out conceptually real quick. I'm not going to like totally diatribe about it, but what I'm talking about is if you have sort of, here's your cell, let this X be an individual cell, right? So we have supercells or clusters of storms, I mean, call it whatever storm mode you want, and they're all separate like this, right? Well, as we go forward throughout the day, some of these storms are going to merge, what we call cell mergers. So this one might move to the northeast, this one might move east, this one might deviate to the southeast. Eventually, you're going to get sort of this convergence zone between all the cells, and then eventually, by the time you get towards, say, later on in the day, you will see this bowing structure sort of drawn how I drew it here. It's sort of a concave look to it, right? That's what we call a bow echo. And bow echoes have a lot of cold pooling behind it, meaning you got cold air behind it. Sort of, it doesn't even look like an X, to be honest with you. It's more so of this ball, right? And so what that does is cold air, remember, sinks. As that hits the ground, that then is going to rush forward in the form of an outflow boundary, and that can lead to damaging straight line winds. It's exactly what we saw here across the Carolinas as indicated by our storm reports. We had a lot of wind reports out towards the Carolinas. It's something that we talked about yesterday for folks. So here it is, came together, came to fruition. I guess the one thing in the forecast from yesterday that maybe didn't go according to plan was that we were still seeing some pretty strong tornadoes well into the evening. I was not expecting that. I would be completely honest with you. I'm a meteorologist and I will admit my faults. And one of the things that I got wrong yesterday was I actually didn't think that we would see a large swath of strong tornadoes like we did. It almost was towards outbreak criteria. Actually, I would argue it was outbreak criteria. We actually had 13 tornado reports yesterday. As I mentioned at the top of the video, 3 confirmed fatalities from the tornado in Tennessee. It's not listed on here, so I assume that's going to be put in at some point. Again, that's from local media reports that I'm citing. But the other thing that's not on here that I noticed is we did also have a tornado emergency last night across Huntsville, Alabama, and really northern Alabama that is yet to be put in. I'm sure the National Weather Service out near Huntsville is going to be doing a damage survey and is likely going to be updating this list. So I know it says 13 tornado reports right now, but this, of course, is probably going to increase. And the same can be said about the wind and the hail reports. We're likely to see those go up as well as more surveys come in and updated reports and information gets fed into the system. So anyway, point is we had a very active day yesterday, and the same is to be said about today. So this is our latest severe weather outlook. We have an enhanced risk, and it's a really broad area. It's from the southeastern United States all the way back towards essentially the Dallas Metroplex and much of eastern Texas. Now, today's setup is going to be slightly different. It also is pretty much derived from the same situation. We have this occluding low that's all the way out here towards the Rockies, and you have sort of this streamlined westerly flow that's moving atop of that surface boundary layer. We'll get into more of that here later on, but the one thing that is going to be different, as you're going to see, just so sort of this preview, is we do have this surface low that's going to move across El Paso and then eventually just slowly move off towards the east into Dallas. Now, I'm concerned particularly about Dallas here just because of the overall setup. I actually think that the highest potential for supercells and really deep convection is going to be somewhere near the Dallas Metroplex and even towards the Red River Valley. And that's going to probably start anywhere between 12 to 2 o'clock this afternoon. It's going to be relatively earlier on in the day before we eventually see, once again, convective cells merging together and then moving off towards the southeast in the form of just some multi-clustered mess, if you will. So we do have an enhanced risk, like I said. This is a pretty nice probability for severe weather. If we look at the day one tornado outlook, we have a 5% across the region. I am not expecting the type of tornadic activity that we saw yesterday. There still is, however, the chance that we do see tornadoes in some parts. And if anything, I would actually argue that the tornado potential, the highest tornado potential, is going to be likely along this warm front near Dallas. I've already mentioned Dallas, and you're going to see why I keep stressing it here during the video. But I would actually make the argument that the highest tornado probabilities are going to be in this spot of the 5%, whereas towards the east, I actually expect more of a damaging wind and hail threat. And speaking of which, here is the day one hail threat. You notice that the 30% SIG is situated right in the same spot that I keep emphasizing. This is because, again, we're going to see that the storm mode earlier on this afternoon to kick things off is going to be in an area that has really robust thermodynamic profiles, very unstable atmosphere that will allow and essentially promote deep convection. And thereby things like really large hail. So that's why you don't see a 30% SIG extended into, say, Georgia, Alabama, Mississippi, for that very reason, because we're going to be talking about a different storm evolution by that point later on in the day. And then finally, with our wind threat, we do see a 30% SIG, and that's pretty much along the enhanced risk. That's going to be for storms, once again, that are going through cold pooling, that are merging and producing damaging straight line winds. So 30% SIG extends for the same area under the enhanced from eastern Texas all the way back into the southeastern United States for places like Georgia, especially Atlanta, and even getting back towards Augusta, and thinking of the town, Charleston, South Carolina. So let's get into the setup. And like I said, guys, I mean, it's relatively interesting. And I will start by going back here. You know what I just noticed? I didn't put up Pivotal. So let's just pull up Pivotal real quick. Actually, I lied. I already have Pivotal. That's what I was looking at. Oh, before I go into the severe weather threat, one other thing I want to stress. You guys know I love talking about flooding. I don't like it. I hate the fact that people do get like flash flooding. It sucks. And also, it's one of the more lethal hazards out there. But I do at least want to go over this very quickly. We do also have a slight risk of flash flooding. There is a reason for that, and that's exactly what I'm about to get into. But I just wanted to highlight that we are once again running the risk of some flash flooding concerns for the same regions that will be expecting severe weather today for, again, Georgia, South Carolina, all the way back west towards eastern Texas. Okay, now let's head all the way back to what I was going to do before, and let's take a look at some of the models for today. And so we're going to go ahead and start first just by looking at sort of the overall jet pattern. And we'll kind of look at the NAM3 CONUS. That's fine for now. But I want to start first by looking at the 500. This, again, is our jet stream. I want to show this to you guys first just to emphasize that the overall large-scale pattern has not changed here. This same system, the same jet flow that's responsible for a lot of the severe weather we've seen across the Central Plains, now the Mississippi Valley region, is also going to be responsible for the severe weather we see today. So what do I mean by that? Well, as I mentioned before, we have an occluded low, an occluded closed low that's out towards the central Rockies. Now, this is going to continue to spin. You're going to notice here as we play this forward that it doesn't really move much, right? So if we go forward in time throughout the day today, keep your eye on the central Rockies. It sort of consolidates its other pressure to the east, but for the most part, it doesn't really move at all. So a lot of your strongest jet flow is going to be positioned right where we see our enhanced risk for severe weather. So at the jet stream level, we're talking about winds, at least even as of right now, being anywhere between 55 to 65 knots. So that's not bad. What's not shown on here is we also have a secondary area of low pressure in the form of a surface low. And it's really small. We might not even be able to see it here on the 850. Actually, we do. If you look really closely here, I'm going to go ahead and zoom in towards Texas. You can actually see that we have another area of low pressure right now out towards the Texas Panhandle and parts of west central Texas. That's actually going to be the catalyst for a lot of our localized supercell potential for the Red River Valley and Dallas, right? So if we go forward in time throughout the day today, you can see that spin. It might be kind of hard to tell, but you notice early on in the day it shows up, and then you see these little splotches here of wind. Those are actually convective cells that have fired off. So it's certainly indicating plenty of instability within this region locally. And then what you'll see eventually later on is these storms moving off towards the east and northeast. So, but I want to start first by looking at Texas. So I'm going to back out of here, the NAM, and we're going to look first at the latest HRRR solution. And what I want to start first is by looking at 0 to 3 above ground level CAPE. What this is telling us is the localized instability from just the ground level, only 3 kilometers high. Anytime you see values of 100 to 200, that's really unstable. And as you can see here on the latest HRRR, this is going to take us to about 1 to 2 p.m. And you notice that your instability is really high, right? So 207. Let's take a look at a sounding here and see what we got going on. That is absolutely contaminated. So let's go back a little bit. Maybe we'll pull another one here and see if it's a little bit less contaminated. That's fine. We can work with that. So this is a sounding, again, this is right near the Dallas Metroplex. A couple things to note here. And again, just as a reminder, this is for around 1, 2 o'clock, right? So we have CAPE value, surface CAPE, near 5,600. That is incredibly unstable, but also, even more impressive, our mixed layer CAPE is also near 5,000 joules per kilogram. So that is incredibly unstable. A lot of potential energy for the atmosphere to tap into, right? And then also, the other thing to note is we have PWatt. Remember how we talked about precipitable water yesterday and how it was so high? Well, today, 1.82 inches of equivalent water, right? So that's how much precipitable water that these storms have to tap into. So I mentioned the flash flooding threat. There's your reason why we have very high PWatt values. That means that our atmosphere is going to be pretty heavily saturated for precipitation and heavy rainfall potential. We mentioned the CAPE. Again, if you look at the SKU-T, which is always what we refer to in meteorology, this is our CAPE profile, that little dash line you see. So you notice how really stout this is. When you see a big CAPE tongue like that, that's telling us there is a crap ton of instability from the ground level all the way up, in this case, to about 12 kilometers. So very, very unstable. Also, 2 other things to highlight on this sounding. Look at the lapse rates. Surface to 3, 8.7 Celsius per kilometer. That is also a indicator of instability, and also one that could support robust updrafts, right? So if we're cooling our air parcel with height, and we're lifting this air parcel from the ground level up, and again, surface to about 3 kilometers, that's telling us that our air parcel is cooling at a whopping 8.7 degrees Celsius per 1 kilometer of air. Or 1 kilometer of distance, I should say. So that's very steep, right? So these storms will certainly have the potential to support really robust updrafts. When you have strong updrafts, that can also create very large hail, because remember, hail is going to crystallize at very high altitudes, right? Very, very high positions within the storm. And so you need a really strong updraft to support that crystallization process, and that way you can essentially keep it elevated before it then falls to the ground. So we're going to see some very large hail today across Texas. That is for sure, once these storms do initiate. The other thing I wanted to point out, last thing on the sounding, is of course the hodograph. We're not seeing that crazy cyclical shape here. However, what is important to note is that while we do have very weak veering, we still do have very elongated shear vectors aloft. So this green, yellow, and light blue that you see has a lot to do with the strong shear aloft. And so that's encompassing, again, sort of the 6 to 9 to 12 kilometer range, so about 6 to 12 kilometers high. So really strong shear aloft, that streamwise shear, is what's going to support the hail as well. So tornadic potential, again, veering is rather low. I think the best tornado potential, though, is going to be in Texas today, in areas that we do see the best veering. But again, it's not as impressive as what we saw yesterday in many parts of the Mississippi Valley. So keep that in mind. But there certainly is definitely the potential for some strong damaging winds in the form of downdrafts, as well as very large hail. So you want to be mindful of that. And guys, if you're in Texas, you really can't catch a damn break, can you, when it comes down to hail? All right, let's quickly take a look here at a couple more products. We'll look at the dew point and wind barbs. This is also going to show you where our warm front, cold front placement is for today. And so as you go forward in time, this is later on this afternoon, you're going to see right here, you can kind of notice it, there's your low pressure. Let me draw that in black for you. here's your low pressure, all right? And your warm front is going to correspond with these wind barbs. So if we're seeing wind barbs kind of out of the east, this is really the warm front placement. And then our cold front is where our winds are backed, so it's going to be right in that area. Any of these storms that fire along the warm front, despite the fact that the veering is rather weak, will have the potential to produce tornadoes. Historically speaking, if you go back to any event, right, storms tend to perform a lot better when they're along the warm front versus just in an open warm sector. And that's because this is where you have your greatest storm relative winds. Your best veering is located right near the warm front. So the closer you are to the warm front, the better tornado potential you have. And so we are expecting some of these storms to fire off near the warm front later on this afternoon. And if it can tap into some of that, again, rather weak veering, but veering, they will have the potential to produce tornadoes based on the deep convection that will be produced today. But as we go later on in the day, you're going to notice that by the time we get to the evening, notice how your deep moisture advection begins to kind of collapse here. This is what we call a convergent boundary. And the best way to indicate that is look where your winds are, right? So here we go from, sort of this low pressure, warm front, cold front, to then this evening, you notice your wind barbs change a bit, and now you have winds coming out of the north and winds coming out of the south, and so you get storms to sort of cluster in this area, and that's what we call a convergent boundary, where cold air meets warmer air. And that's going to happen later on in the evening. So the supercell potential, just like yesterday, expect some discrete activity for a very short window across the Dallas Metroplex later on this afternoon, right around the 12 to 2 o'clock time frame. And then by the time we get to later on this evening, we're going to see a lot of these storms cluster near the convergent boundary. We're going to go from a warm front to essentially this convergent boundary across the deep south. And that's going to be more so of just multi-clustered convective thunderstorms. We're not expecting to see, robust supercells in this area by the evening. It's, again, going to be sort of a clustered mess. So let's see exactly how that pans out. I keep describing it, but why don't you take a look and see for yourself? So here's the afternoon, right? We get some initial convective development along the warm front, but then that quickly dissipates. And then now we see sort of this supercell development. Now, I will actually make the argument that we may see these storms be discrete to semi-discrete here for a bit, about an hour, 2-hour window later on this afternoon. But you notice that as we start to get towards the evening hours, this takes us into 7 o'clock, we still are seeing some robust supercell activity across Texas. However, it's starting to cluster a little bit more. And so as we get into the later evening hours, you see by the time we get towards Alabama, Mississippi, this is really late, right around 8, 9 o'clock p.m. local time, you see that we start to get more of these clustering, right? And now we're just pretty much this QLCS. So at that point, we're a squall line, and that's going to continue to move off towards the east and eventually produce what looks to be a bow echo system indicated here by the HRRR, and that would be producing some damaging straight line winds. If we take this over to the other region that's going to be impacted by severe weather later on tonight into tomorrow morning, let's take a look here at the southeast. We already saw that this storm is going to turn into sort of a bowing segment later on tonight, but this, of course, starting out today, this morning, we see that line that we talked about earlier on in the video. That's going to continue to move off towards the south and east. Again, damaging wind potential there. Could be the isolated threat of a tornado before that eventually clears out of the region later on this afternoon and evening. And then by the time we get to tonight, you notice a lot of clustering going on near the panhandle of Florida and Alabama. And so that's going to be the theme for the rest of today. Multiple rounds of showers and thunderstorms for the deep south and the southeastern United States. The HRRR is showing, again, cold pooling taking place in sort of this bowing segment. And that makes a lot of sense because convergent boundaries tend to force that a lot more because it's forcing a lot of training convection. And so you can get a lot of cell merger and cold pooling to take place along that. And also, as we just established, our environment looks really great for today. Very conducive for, strong damaging straight line wind events like we'll see later on tonight and into tomorrow morning for the region of the southeast circled here in black. Let's look at one more sort of rendition. We will look at the RRFS. And so you're going to notice sort of a similar thing here for much of the United States. And let me just actually go ahead and put on the national view so that way you guys can see it better. Is it going to work? I guess not. All right, let's go to Texas first. That's fine. And maybe it's freezing on me. I think it is. Yeah, it is. Okay. That's fine. Oh, wait, there we go. Okay, so we got the NAM. Let's go to the rapid refresh. Okay, there we go. So rapid refresh, same thing, right? You're going to notice a very similar pattern. And once again, you get this clustering to take place across the southern United States and then eventually forming into this bowing segment by the time our capping inversion sets in. And we get a very strong damaging straight line wind event for this area of the country, again, circled in black. So very high model confidence for today on the severe weather potential. Just to recap, for folks in Texas, you want to be on the lookout for some supercell development, especially near the Dallas Metroplex later on in the early afternoon, before we then see that transition into a damaging wind threat and become more of a line of thunderstorms as that progresses east later on tonight into tomorrow morning for the southern half of the United States. Main threats for today in Texas, especially eastern Texas, is going to be the threat for tornadoes, isolated chance of tornadoes, damaging winds, and extremely large hail. We could be talking about hail greater than baseball size, once again for the same areas that have been hit hard by hail over what seems to be the last few years, right? So again, Dallas Metroplex, eastern Texas, back towards Nacogdoches, and even towards Shreveport later on this afternoon into the early evening. By the time we get to this evening, the main threat is going to be largely damaging winds and very strong straight line damaging wind potential for the areas circled here across the southeast from Mississippi all the way back into the Carolinas. Listen, thank you guys so much for tuning in. If you did enjoy today's content, be sure to like and subscribe and share this video with family and friends who will be impacted by the severe weather potential later on today. And we'll see you back here tomorrow with another weather video. Take care.